Thanks, Gabby. Hi, everyone. My name is Josh Persi. Today, we're meeting to talk about chapters 28 and 29 of Klaus Wilke's The Fundamentals of Data Visualization. Um, Chapter 28 is all about choosing the right software to visualize your data, and chapter 29 is all about finding the story in your data visualization work and how to convey that story. I was a little rushed for time this week, so there's a lot of text, but I think that reflects the nature of these two chapters. They had a lot of text in them. A lot of them are concepts. So maybe we can just go through them and have a discussion. Feel free to interrupt me at any time with your own thoughts. So choosing the right visualization software. By the end of today, I hope that you will be able to identify some considerations to know which visualization software is right for you as a visual designer. The chapter starts out with the author, Klaus Wilke, acknowledging that learning new tools is not trivial. It comes with a learning curve that may or may not be steep, and it'll be difficult for a little while as you learn new tools. So there's certainly validity to the idea that the best tool is the one you're already using and the one you know. But there's a lot of tools to learn. There's always a temptation to go learn like the exciting new visualization technology. And based on some other reading I've done of Klaus Wilke's work, it seems like he would implicitly suggest that you be the judge, you know best which software is right for you. But he spends the rest of the chapter detailing some more specific considerations, yeah, that might help you make that decision. The first sub-chapter or subsection of this chapter is about reproducibility and repeatability. I found this section a little confusing because I found the author, Klaus Wilke, used reproducibility and repeatability, excuse me, in ways that I wasn't familiar with. I'm used to thinking of reproducibility as the ability to like get someone's data, get someone's code, you like execute the entire script and you get the same output. But he seemed to refer to that almost more as repeatability and reproducibility as the ability to like follow the logical thoughts that someone had to reproduce data. So you might end up with a different graphic with different fonts, with different line widths and things like that, but the overall message would be the same. That's the first time I've heard reproducibility mean conceptual reproducibility as opposed to like programmatic reproducibility. At any rate, the author thinks that you want a tool that, if the need arises, can enable down to the pixel repeatability. For example, if you're adding jitter, so you're shifting, say, a scatter plot point up and down by some random amount to minimize the effect of overplotting. To make that graphic repeatable, you need to specify like a random seed to ensure the same amount of random jittering whenever you execute that script, whether it's now or a year in the future. Not every tool can do that. It's, I think, a benefit of scripting tools for data visualization like R, like Python. If you need that kind of repeatability, that level of down to the pixel repeatability, you can, like, there are tools like R and Python, ggplot that make it easy. If you don't, there's no, I guess, strong conviction that just giving someone instructions, like using a tool to conceptually reproduce graphics is like a bad idea. You, in Klaus Wilke's mind, also want a tool that is well suited to data exploration and data presentation. He makes this distinction here to distinguish the parts of a data visualization task where you are exploring the data, you're trying out a bunch of different plots. They're almost all probably not very stylish. They're just quick and dirty, trying to get a sense of what the data looks like, what visuals might be compelling, whether you should use a scatter plot here or a bar chart or what have you. He separates that from which is the data exploration side versus the data presentation side, which is when you've settled on the content, how your graph will look, and it's time to add aesthetics, color things, customize fonts, customize margins and padding, and all this more design-oriented stuff. He thinks you need a tool that can do both, because if you have a tool that can only make high quality, that only excels in the data presentation side of things. If you get asked a relatively trivial question like, what does this look like as a box plot? Or what if you make this other minor tweak? You'll have a hard time implementing that because of the tool's inclination towards the data presentation side of things. So you want a tool, ideally, if you are designing one in your head, that has strong capabilities for data exploration and data presentation. I think this is, again, something that R, Python is well suited to. And another aspect of data presentation is you will want to favor a tool that allows for as much of the data presentation process to be captured by your tool. For example, if you're writing R code to make a graphic, all your all your custom presentation add-ons, like the coloring, the fonts, adding images, and things like that, can all be done in R, which makes R a good tool for data visualization. But if your tool, the tool you're familiar with, the tool you've chosen, doesn't allow for capturing that sort of styling into your presentation layer, it's totally fine to open it up in PowerPoint or Paint or Figma or Canva or whatever the tool is, and like manually copy in or paste in elements you're missing, like a background image or something like that. And I believe, last section in this chapter is you want a tool that separates content and design. This is much the same as the data exploration and presentation dichotomy. Here you want your tool to have functions or functionality that targets the content kind of in isolation, and then targets the design, again, kind of in isolation. So it's easy for you to focus on just the content, get the content right, and then worry about design, or vice versa if the need arises. Or possibly if you're working on a team for the same visualization, someone can handle the content generation and someone else can work on the design components, because they require different skills, different perspectives. The content side is much more typically about statistics, showing the right sort of metrics to answer the question at hand. And design is a lot more artistic, visual, following good design practices, and the skills required to do well in both of those domains don't always overlap. So this is how publishing houses work. They have designers and they have content editors, and that distinction, that separation, is mirrored in tools Klaus Wilke likes, like R, where you have ggplot2. The geoms side of things are the content and like the theme and labeling functions are the design component. I just see a chat here. Yeah, I think that's totally right, Gabby. I think you can do all your pre-processing and like content generation beforehand in separate scripts and then visualize it at the very end. Um, yeah, I'm not sure if like this section seemed a little, how do I put it? I've never really thought about the distinction between the fact that like you set in ggplot2, you set your like theme stuff in a separate theme function as opposed to like setting theme in your geoms, but I guess that's not even true because you set aesthetics in your geoms or like solid colors. So um, I don't really have anything else intelligent to say about this. So I'll leave it to any of you if you want to go on the mic and say something more intelligent. But I think that's the yes, we can ask him during the Q&A. Great idea. I guess the last thing I wanted to end off here on is what tools do you both use? I do most of my work in ggplot2. I assume that's what you are using, but maybe that's naive of me.
Yeah, so I use R for everything. That's the one I've been using for almost 15 years. So I
Mhm,
am like so married to that software that, but I understand what he says at the beginning of the chapter when he says that sometimes you need to invest a little time in instead of complaining about how R is better than Python, for example, just spend that energy and that time into exploring other software that could
mhm,
also help you achieve what you have or what you're trying to do. Because sometimes the other one may do some things easier or in a more efficient manner than the one that you've been using.
mhm,
In the end, and that's what he says in the chapter, is like use whatever works for you and whatever you will give you the graph and the results that you're looking for. Um, so I have been thinking a lot about that, about Python ever since it started to like gain momentum. And I remember even tweeting about this probably in 2021 after the pandemic. And I was like, I have a feeling that I'm gonna have to start learning Python because everybody's talking about that. And I remember a lot of people, I'm an ecologist, so a lot of people in my field were like, no, R is gonna be for here forever. What are you talking about? Python is like, it won't take off as much as you think it will. And I'm like, I think it will, but let's see. And then now it's like it has taken over so many things. So I've been meaning to learn more about it. And there's even a book that's called Py for data analysis. That's like let's start learn Python from zero. And I've been meaning to get into that book club and get it running, etc. But but that's another topic. So I do think that it's good that you are multilingual. However, sometimes just stick to what will give you what you need, right? So for me,
totally.
it's yes, I'm a tidyverse person. Base R is I just my brain just does not work like base. My brain works like in modules and organized like the tidyverse. So I'm a tidy person. So ggplot. However, ggplot has certain things that they cannot do. So then I use like other packages. Like there's one that's called I think Lemon or something.
Hmm,
But those are like accessory packages. But yeah, all my data visualization is in ggplot. Yeah, except maps,
okay.
SF, and other packages.
Yeah, yeah. Yeah, I'm there with you. I'm a big ggplot2 fan and Tidyverse fan.
Mm.
I also want to learn Python. I don't know much about it. So um, if we get that Python for data analysis book club going, I would definitely participate.
Mhm.
Um, I'll mention it just because it uh, is from the same author, Klaus Wilke, but he recently published two blog posts on Blue Sky about how like R is a better language for data science than Python.
Yeah, I saw
So
it.
it had some parallels, like I think to this chapter where he was like, use whatever you like, use whatever you're familiar with. But um, he still sees data visualization as maybe just more data science as like the purview of R than Python. But we'll have to get his opinion on that, I guess, too.
Yeah, let's ask him definitely to explore more of that in the Q&A.
Mhm.
The
I
other thing that is, oh, sorry, go
I
ahead.
was just going to add that I'm not sure if you've read the his blog post on R versus Python, but he now I think really recommends Plot9, the like ggplot2 port to Python.
Mhm.
So like in some sense, like the idea of what tool to use is almost blurred across language lines like
Mhm.
that, because like Plot9 is basically ggplot2 in Python. So
Yeah, okay.
you kind of have the same tool, the same functionality in different incarnations of that tool.
Yeah, see, but when it starts to get like that, then I'm like, then why am I gonna switch? What's the
Yeah,
benefit of me switching?
totally, totally.
Right? If it's gonna bring me some benefit, then I will invest the time to
Hmm.
learn it. Like for example, if a graph or a map, whatever, in R takes me, I'm gonna make something up, 50 lines to make. Oh, don't worry, because Python has so many cool options that in 5 you can get the same thing.
Yeah.
Then I make the switch.
Hmm.
But if it's gonna be the same, I think the only benefit there is that if you started with Python and then sure, continue with Python and then use that other package. But if I'm in
Hmm.
R, the switch is not like, yeah, it's not worth
Not
it.
very attractive. Yeah.
The other thing that I wanted to mention is the first thing that was on the slides, the reproducibility and replicability, no, the reproducibility and the repeatability. So I agree with him. That's how I've seen it. And there's a third verb that is replicability. So these are super important, I think, in data science and are worth talking more about them. I love talking about these ideas. So repeatability, I agree that it's like essentially you copy paste and then boom, you execute a script and the entire thing gives you exactly the same graph that it's either in the presentation, in the report, or in the manuscript in a published journal or something. So that is like there are no errors, the colors are the same. You don't have to adjust anything because the thing looks exactly the same, like a mirror. Um, then we have reproducibility and replicability. So if I remember correctly, reproducibility means that you have the same hypothesis that this person has, and you have the same data. You want to achieve the same thing, but maybe you're gonna go through it through a different path. But at the end, your conclusions are gonna be the same. So it's just that you used a different path. And then replicability, if I remember correctly, but we can always check the literature. Replicability means that, so you see the framework that these people used to analyze this data set. Now you have a different data set. You want to use the same framework and the same hypothesis, let's say, but you have a different set of data. And then you use that same framework. So if they did a certain model, you use the same one, but in this case, apply to your data. And then you have similar results. Well, not similar results, but the model and the framework
Hmm.
allows you to analyze the data in the same manner that the other people
Yeah.
did.
A similar type of output.
Yeah, exactly. So then that means that uh, it works. Essentially, the framework works. So I think those three verbs are super important to talk about when we're talking about R because, for example, I have had this discussion with other people that in order to make maps, they use QGIS, or the same thing with data analysis, people use Excel. And that's all great. The problem is when you want to reproduce or even replicate or repeat the analysis, you have to remember the steps. You have to rely on your memory because or unless you take screen captures and then you have like your little how to or you put it
Hmm.
in words or something, it's not efficient. In R, you have your script. So either you run it all again, or you just like you go and adjust it and do things like that. But you already have something to work on. So I think that that's huge in data science. And that is the selling point for me to convince someone to learn how to code, because a lot of people are so against it. And they're like, no, QGIS, it's just more, it's easier. And I'm like, yeah, sure, in 5 years, if you can remember how to do this analysis, then go ahead. My memory does not work like that. Good luck to you. I just wanted to add that little piece of yeah.
Thank you. That's actually really interesting to me because I think that I'm probably mistaken on what those terms like reproducibility and repeatability mean. Did you get that from like a book or something that you could link? I would love
Yeah, I
to
think
bring it to
put
my
it
team.
in the data for in R for
Data
data science.
science?
Is that the basic book R for data science, I think it's called.
Yeah, yeah, by
Might be
Hadley.
here. Let me check. So
Okay.
I have here, let's see, reproducibility. No, it's not here. I think I've seen it. Could it be in the ggplot? But I've read it somewhere. Otherwise, it's not either. It's not here either. I've seen it somewhere.
Okay.
I'll look around and then put the reference
Yeah.
in
If I don't want to like give you homework, but if you're just out and about living your normal life and you like happen to stumble across it, I would be happy to read it myself.
no worries. Yeah. I'm pretty sure there are books that talk about that. I'm sure because that's how I
Okay.
learned about it. Yeah. I'll
I'll do
look.
some digging myself too,
Yeah.
and share it if I find anything.
Yeah,
Okay. Any other thoughts on chapter 28?
yeah, this one was good. I think it gives us a lot of things to ask in the Q&A.
Yeah, agreed. Agreed.
Let's move on to the other one. Yeah.
Okay. So chapter 29, telling a story and making a point. I must have forgotten to write a learning objective. I think if I had to make one up on the fly, it would be something along the lines of, by the end of today, you will be able to understand how to convey your data visualization like a story. Um, what is a story? Humans are natural storytellers. We make up stories even where none exist, which is possibly something to be extra aware of as a visualizer of data. If you don't provide a story to accompany your data visualization, your audience will make one up and they likely will make up the wrong story and draw the wrong conclusions from your data visualization. So I think the author rather thinks that you should provide a story with your data visualization, or else the audience will be led astray. And this ties in with some other data visualization stuff I was reading. Um, I don't have a reference for this, so take it with a grain of salt. That even like a bar graph that shows data is not interpreted the same by like different people. So you can have the same graphic, it shows like the same dimensions of proportionality. You show it to various people and they draw different conclusions from it because of their own inherent bias and worldviews. Um, so I think, need to like add story to your data visualizations because data visualizations are not objective. People come to them with all of their background bias and worldviews and extract meaning from your data in alignment with those worldviews. So stories are important. We ought to include them. How can we think about them? I suppose story writers have structures that they rely on either implicitly or explicitly. Things like the lead development resolution, where these are like the names of the different steps in these frameworks. For the lead, it might be, I believe, like a the opening, the development is the middle, and the resolution is the end, how the story wraps up. The news world uses this one as it does for lead development. There are some other story frameworks that I'm not particularly familiar with, but the action background development climax ending seems vaguely familiar to me, like a hero's story. If either of you are familiar with that, where the hero gets a like call to adventure, goes on an adventure, is changed, comes back, life is different than it was before the adventure. So if you know these, I think you can employ them well in your data visualization. And if not, maybe something to brush up on, because humans like stories. Make a figure for the generals it really boils down to one idea, that you should use simpler graphics as much as possible. Simple is good, complex is less good. Acknowledging that at some times you may struggle to make a simpler graph, but simpler graphs are easier to understand. You are less likely to be misled by them, and they are faster to interpret. Time is engagement, and if it takes a lot of time to understand your graphic, people are going to move on. So if you want someone to take your data insights and like internalize it, it needs to be quickly interpretable, which means the graphic needs to be simple. So simple graphics are good. With the rise of like R and ggplot2 and other very feature-rich plotting libraries, Klaus Wilke has noticed a trend for data visualizations to be like jam-packed with all this information, and he finds them, or rather he finds, I don't want to say what he finds. He has noticed this trend, and that's something that I've noticed as well, that, for example, if you browse certain tidy, so if you browse the Tidy Tuesday like feed on Blue Sky, or formerly Twitter, not formerly Twitter, on Twitter, some of the graphs are like very complex and feature rich, and they're visually very impressive, but it's hard to understand what they're trying to tell you. So if you're designing data visualization for insights as opposed to like artistic endeavors, try to keep it simple. Use more simple graphs rather than one very complex graph, and this will help people understand your work. This section is if you do need a complex figure, or even actually, I think if you need a simple figure, and depending on the audience you're presenting to, try to build up towards complex figures. So Klaus Wilke used the example of small multiples, or like faceted graphs, where instead of showing maybe the entire graphic, where you have, say, 2 rows and 4 columns, so 8 graphs in total, you would just show one graphic or one small multiple, get the audience familiar with that graphic, the axes, the type of data being presented, and then you would expand it to show all of the multiples. This is something to make it easier for the audience to understand your graphic. From my own personal experience, I've definitely been kind of stupefied by complex graphics, where I just look at them and I don't know where to look first. I'm looking at the axes, I'm looking at the titles, I'm looking at the points. It's hard to incrementally understand it. So Klaus Wilke says you should build up towards complex figures by showing small multiples, for example. Another idea that I've gotten from former advisors of mine is, if you're presenting at, say, a conference, or virtual or in person, and you're displaying a plot, you can plot like the axes with the titles first and white out all of the data. So you just say like, I'm going to show you a graph here are the x-axes. We have like day of the year on the x and number of kittens on the y. And this is like the framework. And then you add in, like you advance the next slide and you show the actual data. So your audience is already primed to understand the axes at least of your plot. So that's just something I've gotten from my advisors in the past and is related to building more complex figures. And Klaus Wilke acknowledges that this is hard to do for posts to social media, for example, where you're usually only plotting one graph, and there's not a lot of opportunity to add in these layers of complexity as separate graphics. In a larger set of figures, as you might use for like a publication, a journal article, Klaus Wilke recommends that you make your individual figures memorable by making them different, um, using different geoms, for example, like a bar plot versus a scatter plot versus a box plot versus other types of graphs. So just so that they don't all look like the exact same graphic. And he also had this idea of using isotype graphics. I'm going to look at the graphic, look at his plot for a second. He suggests using what he called, and this is new to me, isotype graphs, which feels to me like I had some negative reaction to this at first, just because it seems so maybe fun and not serious data science work. But I think that's my own biases coming to the fore. But he says that this makes this graphic more interesting, more memorable. I wasn't able to find a real reason why this is like not a valid graph. The spacing works out. The thing that is 7 or 8 million is roughly 2 times the size of the thing that is roughly 4 million. So the spacing all works out. My partner looking at this actually commented that the dogs seem to take up more like vertical space and then like say the fish, like the dog is taller than the fish is, just because of the images that are used. So it, like if we want to be super nitpicky, you might say that your eye is drawn more to the dogs because the proportion of the image that is actually taken up by the thing is bigger in the dog, whereas for the fish, it's maybe not as much. But I'd be curious to hear what you guys have to think about isotype graphs if you've used them before. I could see them being particularly useful if you have like consistently shaped things, like I don't know, flags or circles or emojis or something. Just that all have like the same dimensionality. But we can come back to that in a minute.
Mm. Yeah,
Oh,
so with
please.
that,
Mhm.
so I think that's a silly example. And like I mentioned before, I'm an ecologist and I also draw something called silhouettes. Right now they're housed in philopic.org. And what people do, because I have had a lot of researchers like send me emails asking me to draw silhouettes for them. So that is, think about that dog, but instead of looking like a dog, it's all blacked out. So it's just a silhouette. But other people do also images like that, like that one dog. So instead of having like 10 dogs there or half a dog or what they do is, let's say I'm trying to find examples, but I couldn't. But I'm cited in so many papers because of that. Not cited, but my name appears there, not because I'm a co-author, but because they used my images and they're copyrighted.
Mhm.
So what they do is imagine that instead of having those like bar graphs, it was like a line graph. At the end of each line, they put just one silhouette. So
Mhm.
what that does is just it symbolizes, you could put there like by color and then in the legend say dog, cat, fish. But if you just put a little something there that
Yeah.
symbolizes that's a doggy, this is like a cat or something, it looks a little bit more aesthetically pleasing. It's not for everyone. Some people hate them, and
Mhm.
that's true. So that makes a little bit more sense than the one that he put. I feel like that's more of a silly example, to be honest with you. But in reality, like those kinds of things, I feel I agree with him. They can be more memorable.
Mhm.
So I'll try to put more examples in Slack, some of the ones that I've done and others that have used, like I said, my Philopic silhouettes. Um, so yeah, I think that's more where that argument can be applied.
Okay. Okay. Awesome. Thank you. I think the last section in this book is very similar to this one, be consistent but don't be repetitive. Oh, sorry, making your figures memorable. This is the last section. Be consistent but don't be repetitive. So in a larger set of graphics, again, like you might make 3 or 4 or 5 for a journal article or a blog post or something, you want to ensure consistency using probably the same theme, the same color palette, the same font, but you don't want to make 5 horizontal bar graphs, just because the audience is going to have a hard time to remember which bar graph is which. They will all kind of blur together. So he suggests using various types of graphics, so a bar chart, a box plot, scatter plot. Find a way in your series of graphics to make use of various styles and types of plots. Um, and one thing that I'll definitely be taking away is his idea that you can show raw data, maybe for the first graphic, and then you can show derived variables for subsequent graphics. That's seems really nice to me. And he provides an example of it here, where he's showing the raw data, like not aggregated in any way. I guess this is daily stock price over the years, so you can get a sense of like the raw data that stock price of Facebook in general has increased from 2013 to 2017. And then he uses this derived statistic where it's percent increase, I think, from 2013 to 2017, something like that, which is probably it's a simpler graphic, and it's more, I guess, to the point, and the message is clearer that the percent increase for Facebook is greater than all these other companies than if you plotted that graphic just like this, where you could probably come to the same conclusion, but it wouldn't be as immediate as if you used a derived or a graphic on derived measures like this. The only other thought I had about this is I fall into this trap probably very regularly, where I have one type of graph that works really well for a data set for a series of graphics, and I end up making like 5 bar plots. I hear his advice that you should switch it up, and I think it's good advice. But I also have to fight the like internal voice in my head that says like the bar chart is the simplest and it works well for all of these types of graphs. It's boring, it's not memorable, but like it's otherwise good. So I think I have to explore other plot options and see how I can make them just as good as like the bar plot, for example. Okay, I think that's everything. That's the end of the book. The end of chapter 29. I would be keen to hear what you folks thought of it. If you have any questions, comments, thoughts.
So I love that last part about the derived variables or derived yeah, variables in ways to see the data or to showcase your data. So I have some thoughts on that. I think that what separates a data scientist from like an experienced data scientist, like anybody can do the raw data, and that includes ChatGPT, right? Like, or how is it that Australians call it? Chappy or something like that. I don't
Oh,
know. But
really? Okay.
there's a name for that. But anyway, so even ChatGPT can do the raw one. However, the derived quantities, I feel like, or the derived variables, that takes a bit more thinking, right? And then so you start thinking, okay, so let's start with the raw things, and then some of those are going to be all bar graphs, right? But then you start to think, what do I want to convey to the public? What is it that I want them to focus on? And then that's how you sometimes arrive to those derived variables. Because like with the Facebook example, you start thinking, well, I don't really care for them to see the trend of how much it has increased. I rather they focus their attention on the difference in how much Facebook has grown from 2012 to 2025, whatever, versus Apple, for example. Like the gap is tremendous. So then let's show that. That's not going to be under your raw data. So it demands from you a little bit more, yeah, storytelling and a different type of thinking about your data. And I think that that's one of my favorite parts of data visualization. And it's like it's not easy, and it's definitely not easy. To your point of wanting to learn more about different graphs, etc. So we're gonna start in January because, to be honest, December we need a break. Not that I hate you guys, but I think we all need a break. I have so many things I
Totally.
have to do. This book has been amazing and I've loved it so much. Some things were like very basic, but others have been like, oh, great. Um, so in January, we're gonna start reading the Nicola Rennie's book on data visualization. And I think that that book is going to help you explore those graphs and those ideas. It's all in R. So if you want to join that book club, then what you need to do is just sign up your availability in January, obviously not right now, and say what times work for you and what days. And that way, join that channel. And then that way we can sort of like find a time that works for all of us. It's probably going to start after January 5th because, we want to start well, but not that early.
Yeah.
So
Yeah.
so yeah, so something like that. And I think that book is going to help us really dive into the coding and the true ways of visualizing data in R. So just a little thought.
Thank you. Yeah, I'm definitely gonna sign up right now.
Yeah, the channel is TT Cookbook, I think,
Yeah. Book club,
or
TT
book club.
cookbook.
I think that's the name of the channel. I forget.
Oh, okay. Okay. No, I think you're right. I think you're right.
TT Cookbook. Yeah. So then join there and yeah, so there's gonna be like a shiny app that's gonna allow you to input your dates and times that you're available.
Okay. Yeah. Awesome.
I highly recommend that one because that book is like a brand new, like brand new. It hasn't even been printed, but it's ready. It's just
Nicola Rennie is fantastic. Like I
no.
don't know her personally, but just her work and like I've followed her on Blue Sky. She's like a rock star in
I
the data
know.
visualization space.
I've been on this for so long that I even remember her first, like when she started putting all her, like when she started, I guess, posting her figures and everything on Tidy Tuesday and all of that, on Twitter, and then we all moved to Blue Sky. But yeah, she's the best. I'm pretty sure she's gonna want to do a Q&A. I am
Okay.
100% thinking that that's going to be the case. I'm even thinking about doing, if she's up to it, I still need to explore the book and see if we can do two, one in the middle and then one at the end, so that we don't, because at the end we don't remember what the first chapters were. Like we are all
Yeah.
like, what's my name? You know what I mean? Like nobody knows. So then if we can do two and then divide the Q&As into two, I think she would be, but I don't know. I don't want to speak for her, but I think she'd be okay with that.
Okay.
Yeah, yeah,
Awesome. Sounds great to me.
yeah. So that was a little preview for everyone else that's watching the recording of this too. If you guys are interested, please join there. We're gonna start in January, and I'm very excited about that. I'm gonna leave the cohort too, but it's just for having someone there to organize things. We're all gonna be a team presenting and all of that. So for now, if there's anyone else that wants to comment something, let's go ahead. And if not, then we can just end the book club.
Nothing from me.
Okay. Veneta, do you want to say something?
Um, no, I had really great time with you guys, and the book was really interesting. I find that it is very important to actually understand the concept of visualization, and then you can pick any tool like you like or you feel good working with. But it's the concept that makes everything else afterwards be make has a meaning.
Absolutely. Yeah, like know the theory, know the basics, and then you can move on to the language that you pick, R, Python, whatever. Yeah, Julia, I don't know. All right, you guys, this has been so much fun. Thank you, everyone. And I guess I'll see you in 2 weeks for the Q&A.
Yeah.
Okay.
Thank you.
Sounds
All
good.
right. Bye, you guys.
Thanks,
Have
everyone.
a
Bye.
Take
lovely
care.
weekend and Thanksgiving for those of you who celebrate. Bye.
Thank you.
Thanks, everyone. Bye bye.